All right, hello Chem 20s. Welcome to your first online lesson. So we kind of left off before break talking about parts per million, and percent by mass. So although those are some units of concentration, they're not really the important one. So the one I really want you to focus on as we go through this online adventure is going to be on molar concentration, because this is the one that we use in Chem 20. So molar concentration is the most common unit in chemistry. It is defined as the amount of moles of solute dissolved in 1 liter of solution. Okay, so this means unit-wise, we're always going to be looking for moles per liter. Okay, and if you remember back to when we did some of that moles and molar mass calculations way back at the beginning, we were reviewing some Science 10, we talked about doing unit analysis, right? We talked about always thinking about what's the unit I'm looking for and where am I going to place things to be able to get them where I need them to be, right? So although I just wrote this as moles per liter, right, the other way to write this, I'm going to tell you now, my trackpad writing is not so good, but hopefully by the end of all of this, I'm going to be a pro at this. So you're going to wind up with moles per liter, right? So remember we talked about things going on the bottom, or the bottom, things going on the top. That's the same thing that we're going to be thinking about when we do our molar concentration. So steps are going to be the same as what we have done before, right? We've always talked about how the first thing we want to do is list our givens. Right? Once we've listed our givens, we then want to determine what unit we are trying to get. So in the case of molar concentration, I'm trying to get moles over liters, right? Then we said, look at your givens and place one of them that has the unit we want. Right, so in this case, either I could start by placing the moles part, or I could start by placing the liters part. And then, just like we did before, we're going to either eliminate until we get what we want, or we're just going to place until we get what we want. Then we're going to do our actual calculations and get our answer from there, making sure that we're watching out for our significant digits. All right, so first example. Sorry, just made the screen a little bigger. It was kind of cutting off what we had. So our first example says, what is the concentration of a solution made by dissolving 0.75 moles of NaCl into 250 mils of water? Okay, so first thing we want to do is we want to list our givens. So we've been told how many moles, right? We were told that we had 0.75 moles. So we know that N, because that's the symbol for moles, is equal to 0.75 moles. Right? The other thing we've been given is the volume. We were told it was 250 mils of water. You're going to find in chemistry we almost always want liters. So to convert milliliters to liters, we're going to divide by 1,000. Okay, so we have our two givens here of 0.75 moles and 0.025 liters. So for the most part, how we represent concentration, you'll find if you look at some of the CBE Learn stuff, they probably just use a C. I tend to use square brackets. So by writing NaCl inside of square brackets, that implies that I'm going to calculate the concentration of it. Okay, and like we talked about before, we want to think about what those units we're looking for are, and they are moles per liter. So I have two givens, right? I have moles here and I have liters over here. So really I could choose to start with either one of these because I know the moles has to go on the top and I know the liters, because it's down here on the bottom, has to go on the bottom. So you can kind of pick whichever one you want to start with. Usually you guys like to start with the one that's on the top, right? So we could say 0.75 moles, and we can put that over 1, right? Remember we talked about how if there wasn't a second part to it, we would just use a 1, okay? So that gives us our first part. And then we need to place those liters. So if we think about where they need to go on the bottom. So the only way for me to get that on the bottom with it on the top right now is to just put a 1 on the top, and then on the bottom to put that 0.250 liters. Right, now when we look at it, we have 0.75 moles on the top, and then we have that 0.250 liters on the bottom. Remember, we want to put them as separate things because they were given to us as separate givens. When we go to calculate this in our calculator, we're just going to do 0.75 divided by 0.25, right? Because remember, we can choose to do the ones if we want, but it doesn't matter. If something is below the line, we are dividing. If something is above the line, we are multiplying, which is why either I can enter this as 0.75 divided by 1, then times 1 divided by 0.25, or I can just get rid of those ones, okay? Once we do that, we can go ahead and get our answer. Okay, so your calculator should say 3. We do need to worry about significant digits. 0.75 had only 2, so we're going to say 3.0 moles per liter. Okay, so this is the simplest kind. We have moles, we have liters. We're literally just placing both of those where we need them to be. Okay, so here's our next one. This one's a little different in that it gave you a mass instead of the number of moles. So this one says 100 mils of saline solution contains 0.900 grams of sodium chloride. What is the molar concentration? So what's a little bit different in this one is the only way that we can get the moles, right? Look at your units. We have liters out of here and we have grams. We need to get moles per liter. So we got the liter part covered, but we don't have the moles part covered. To switch grams to moles, we can use molar math. So go ahead and get your red book out. Hopefully you have that. If not, you can literally just go online and Google Chemistry 30 data booklet and you'll be able to find that there. Okay, so we want to list our givens. We have that the volume is 0.100 liters. We have the mass is 0.900 grams. We then went and found molar mass out of our data booklet, and we come up with 58.44 grams per mole. So, similar to the last question, we're still looking for the concentration of that sodium chloride, right? So we're still looking ultimately to get those units, like we talked about, of moles per liter. So if I want to start by placing moles first, I look here, this is liters. That doesn't have what I want. This is grams. This isn't the moles that I want. Oh, look, here's my moles. I want to start with this. So, problem, right now moles is on the bottom. You look down here, moles needs to be on the top. How we're going to fix that, we're just going to flip the whole thing over, okay? So, we're going to write moles, and we're going to put that over our 58.44 grams. Okay, that gives us our moles. Now we look at this, we have grams. We know we don't want grams because when we look here, there's no grams in it. So the way for us to get rid of our grams, right? Remember we talked about before, we would then multiply. Well, that was not a very straight line. Let's pretend that's a straight line. If I want to get rid of grams, I need it to go up top. So I know that that mass number is going to have to go up here. So 0.900 grams. Again, there's not really anything on the other part of that number, but that's okay. We can fix that. We can just put a 1 down there, right? So now when we look at it, we can get rid of that unit of grams. Now it's gone. Okay, so we now have moles. We still need that last piece, right? We need to get moles per liter. So to fix that, we can just put a 1 on top, right? And then, well, that didn't do what I wanted it to do. We can put a 1 on top, and on the bottom, we can put that 0.1 liters, right? And now when we look at it, grams are gone. We're left with moles per liter, and we can go ahead and figure out what this answer actually is. So to get your answer, like we said before, in this case, I have to use the 1 that's up here next to moles, and that's because the 58.44 is down on the bottom. So we're going to do 1 divided by 58.44 times by that 0.9, Again, I can do these ones if I want, but I don't have to. And then I'm going to divide by 0.1 because it's down on the bottom. So significant digits, I can have 3. So 0.154 moles per, not question mark, per liter. Okay. Okay, so one more example just to show you how to do this again. So a solution is made by dissolving 0.5 grams of potassium chlorate. So we have a mass equal to 0.50 grams. We know the volume. We're told it's 500 mils, so 0.500 liters. And then we need to go get a molar mass. So we need to figure out what potassium chlorate is. It's KClO3. So we need 1 K, 1 Cl, 3 O's. We put all of that together. We should be coming up with 122.55 grams per mole. Okay, so we want to then go ahead and calculate our concentration. So concentration of KClO3. Okay, thinking about units again, we want to start with those moles. We find that moles over here in molar mass, just like we talked about before. We got to flip this over so that we get the moles on top, because right now it's on the bottom. So we're going to flip it, and we're going to write it as moles over 122.5 grams. Okay, then next thing we need to do is we need to get rid of the grams. We're going to get rid of the grams using mass, just like we did before. So 0.50 grams. Also, like we talked about before, we're just going to put it over 1. This then is going to let us cancel out our grams. Okay, now we just have the moles. We need to get the liters. So that means we know that those liters need to go on the bottom, right? So one's going to go on top, and then on the bottom of that, we're going to put in that 0.500 liters. Okay, so 1 divided by 122.55 times 0.5 divided by 0.5. We do that in our calculator. Thinking about our significant digits, we're allowed to have 2. So either you can write it as 0.0082 moles per liter, or you could choose to go to scientific notation and write it as 8.2 times 10 to the negative 3 moles per liter. Okay, either of those are options that you can do.